Okay, given a string, we're going to find the largest palindrome within that string. So say we have A, B, B, A, C, AC. Then we would be wanting to return A, B, B, A as our largest palindromic substring. So to find this, we're going to test out the even and the odd palindromes or possible palindromes within the string. So for odds, we would have kind of a midpoint, and we're going to look at the elements to the left and the right of there, and we'll keep spreading out as long as they're elements and as long as they keep matching. For evens, we can look at them as if there's like a midpoint in the middle, so side by side, and then spread out accordingly as there are matches. Okay, so what we're going to do is go ahead and write our function. It's going to return a string that is the actual palindrome substring. So in this case, it would return AABBAA. So just call it get longest palindrome, and it takes in a string. Okay. First, we can do some checks just to make sure that the string isn't empty. And we can also check and see if it only has one element. We can decide, is one element a palindrome? That's up to the interviewer. If it is, you can just return the string itself. Okay, and then otherwise we'll get into our algorithm. So we're going to want to keep track of a max and a start position, so we know where our palindrome starts, and we'll loop through. We can start at 1 so that we can go and look. If we start at 1, then we're able to look backwards and forwards without hitting the end of the string, or without going over the end of the string. Okay, and so for in I equals 1, I is less than string.length, and I plus plus. Okay, so we have, first we'll test for odds. We got to look at the odds. Okay, so in this case, we would want our low to equal I minus 1 and our high to equal I plus 1, so that we're on either side of I. So while low is greater than or equal to 0, and high is less than the length of the string, and they're equal. So and string at low equals string at high. So while that, we want to test to see if we have a new max. So if high minus low plus 1 equals, is greater than max, then we know we need to set our start equal to low, and max becomes high minus low plus 1. And then we know that we need to do high plus plus, low minus minus, and it'll keep going through that while loop. Okay, and then we want to look at the evens. So in this case, low equals I minus 1, high equals I, and then while low is greater than or equal to 0, and high is less than the string length, and string at low equals string at high. And then we check our max. And start equals low. Max equals high minus low plus 1. And then high plus plus, low minus minus. And that should take care of that. So then we end our for loop. And then we would return string dot substring at low, start, sorry, we kept start, comma, max. Okay. Oh, and we should probably have something where if max, probably before our return, can just kind of move this down. So we've got space. And then if max equals 0, then we want to return a message that we didn't find anything. Okay. Otherwise, we're going to return that substring. Okay, end of function. So let's go ahead and walk through this with a test. Okay, so we can do A, B, A, C, A, and D. Okay, so we know we need to keep track of max, start, low, high, and I. Okay, so here we start max at 0, start is at 0. We go in, our string is not equal to 0, our string is not equal to 1, so we don't go into those tests. And then we go into our for loop, I starts at 1. And then we're looking at the odds, low equals I minus 1, so low is 0. high equals I plus 1, so high is 2. So we've got low. Actually, let's number these. Okay, so we've got low and we've got high. All right, so we look in there. Well, low is greater than 0 and high is less than string length, which our string length is 7. Then, and string low is equal to string high. Well, that case doesn't hold true. So we go down into out of that while loop and go in low equals I minus 1, which is still 0. High equals I, which is 1. So we're looking here. And then while low is greater than 0, it is, and high is less than string length, it is. And string at low equals string at high, which A equals A. We go in if max is less than high minus low plus 1, which high minus low is 1 plus 1 is 2. So, and max is less than that, then we know start equals low. So start is 0, which it already is. And then max equals high minus low plus 1, so max equals 2. Then high plus plus, low minus minus. And we go back to our while loop. While low is greater or equal to 0, it's not, so we get kicked out of that while loop. We go down here and we go back around. I plus plus, so now I is 2. And it says here, int low equals I minus 1. So low is 2 minus 1, which is 1. And high is I plus 1, so that's 3. So we've got low and high. And while low is greater than 1 and high is less than string length, which they are, and our string at I, or our string at low and our string at high are equal, which they are, then if high minus low plus 1 is greater than max, so if 3 minus 1, which is 2, plus 1 is 3, is greater than max, which it is, then start equals low and max equals 3. And then we go in and high plus plus, low minus minus, so high is now 4, low is 0. And we go back in, low is still greater than or equal to 0, high is less than string length, and string at low, which is here. And does that equal string at high? No, it doesn't. So we get out of there and then we go and we do our evens. So low equals I minus 1, so low equals 1. High, and then high equals 2. So we're here. And those don't equal, so we know that our while loop will not kick off. So we go back around, I plus plus, I is now 3. And we go in, int low equals I minus 1, so low is 2. And high is I plus 1, so high is 4. Okay, and we see we've got 2 and 4, B and C. Those are not equal to each other, so we know our while loop will fail if, and then we go down and we look at our evens. I minus 1 is low, so that's 2. I and high is I, so high is 3. And so we go in our while loop. Those are not equal, we know it will fail. And then we go I plus plus, I is now 4. And low is now I minus 1, so it's 3. High is I plus 1, so it's 5. So we're looking at 3 and 5. And low is greater than 0, high is less than the string length, and string at low and string at high equal each other. So we go in if high minus low plus 1 is greater than max. So we look at that. High is 5, minus 3 is 2, plus 1 is 3. It's not greater than max, so we don't need to actually do anything. High plus plus, low minus minus, so high is 6, low is 2. So high goes to 6, low goes to 2. And we're in our while loop still, and B does not equal D, so that while loop will fail. And we go back around, I plus plus, I is now 5. 5 is less than 7, or 5 is less, yeah, 5 is less than 7, so we keep going. And low is I minus 1, so low is 4, and high is I plus 1, so high is 6. Okay, and then we go into our while. If low is greater than or equal to 0, which it is, if high is less than string length, 6 is less than 7, we can go in, and if string low equals string at high, it does not equal, so we do not pass that while loop. And then we look at the evens. Low equals I minus 1, so low is 4, and high is 5. Okay, and then we go down to our while loop. Is C equal to A? No, it's not. We fail that. We go out of there, I plus plus. I is now 6. 6 is less than 7, so we come in, and int low equals I minus 1, so low is now 5. And then high, I plus 1. So high is 7, which we know doesn't exist. We go into our while loop. Low is greater than or equal to 0, but high is not less than string.length, which is 7. So we don't pass that while loop. We go down. Now low equals I minus 1, which is 5. And high equals I, which is 6. The while loop goes in, and it says, is A equal to D? No, it's not. It fails. We don't execute that while loop. And then I plus plus, I is now 7. 7 is not less than 7. So we get out of our for loop. We come down here. If max equals 0, well, max equals 3. So we don't do that. And then return string substring from start to max. So we're going from start to max. So that would be returning A, B, A. All right, and the complexity of this is O of n squared, because we basically have to go through each element potentially. If they are all matching, we would have to go through every possible combination of substring. But it is done in constant space.